So, welcome to this session about containers in Java. And it's basically highlight my experience and my team experience while deploying Java applications in containers. So before jumping into the slides, I want to know you guys better and how you are working with containers in Java. So there is a slide missing here. Oops. I think this is the... Okay, yeah. I deleted this, accidentally, this slide. Okay, test. Yeah. So I go with this one, no worries. So, I just want to do a quick poll to understand you guys better. So, how many of you are working with containers? Cool, that's around 95%. And how many of you are working with Java or JVM applications and containers? Cool, that's around 80%. Are you using Java and containers in production? That's 60%. And what are you using as orchestration tool? Kubernetes? Cool, that's 40%. And how about this? Do you agree with this statement? So I'm just kidding. So this is the boring slide. So I'm Mohammed. I work for a DevOps company in Morocco called XHub. I love everything related to microservices, cloud-native apps, and Java, obviously. So my talk will highlight basically the story of a Java developer called Furro. And Furro is a Java developer who has been working with Java for a couple of years now, and he truly believes in the power and limits of code. And he started hearing about this relatively new technology called containers, and he wanted to start playing with it, see what features it offers, and what limitations it comes with. So my talk will highlight basically his story, starting with somehow the philosophical question, is it a good idea to put a Java application inside a container? We will discuss afterward how to create effective Java images that are both smaller, faster, and secure. We will see some tools and libraries that make working with Java and containers a lot more fun. We will afterward highlight the things that we should know and the things that we should avoid before putting a Java application into a container and deploy it into production. And finally, we will see all the features that has been added to Java to make it more container aware. And you probably know that nowadays containers are everywhere, and they are used for a wide range of applications. From the slide, there is something with the slides. Okay. Just a minute. The resolution. Arrangement, not this one. Where it should be. Scale, okay. Yeah. Oh, okay. Now it looks good. Okay. So I was saying that containers nowadays are everywhere, and they are used for a wide range of applications, from small, fast serverless applications to huge enterprise monolith application. And that's because containers offer a great number of benefits. They make deployment a lot more easier. They make scaling your applications up and down a lot more fun. They advocate the use of decoupled architecture and the microservice architecture. They encourage the use of immutable infrastructure. And in the immutable infrastructure, once an artifact is created, it cannot be modified via user data. And some orchestration tools like Kubernetes, the immutability goes beyond the infrastructure to embrace the way you configure your cluster. So everything in Kubernetes and many orchestration tools is declarative. So you declare the desired state and how you want the real world to be, and it's the job of your orchestration tool to match the desired state with the real world. Containers also enables us to more efficient resources utilization, and they have a rich and vibrant ecosystem with many tools and libraries that make working with them a lot more fun. And the backbone technology behind containers, and you probably know this before, but very briefly, are namespaces and C groups. So namespaces are used for providing different isolated view on the system. So each process will have its own view on different namespaces, like process ID, network ID, user ID, and so on. C groups, on the other hand, are used for limiting and measuring for the resources that can be used by a process. So in C groups, each subsystem, like memory, CPU, network I/O, block I/O, each subsystem form a tree structure or a hierarchy of nodes, and each process belongs to one node and one node only in each hierarchy. So given a process, it will belong to one node for CPU, one node for memory, one node for network I/O, one node for block I/O, and so on and so forth. So initially, when the system boots, there's only one node, the root container. And the first processes belongs actually to this node. So if you think about it, even if you are not using containers yet, you are just using one big container with no limitation and no constraints. So with that, Furu starts to consider using containers. And he starts asking himself, is it actually a good idea to use a Java application with containers? Especially that the JVM offers by itself a great number of benefits. So the JVM is hardware and OS agnostic, and it's runtime adaptive, which means that the JVM will try to tune itself and adapt itself to ensure the best performance on the execution environment. But Furu decided to give it a try, and after reading a couple of tutorials, he came up with this Docker file. So let's be honest, this is not the best Docker file that you can find out there, but he built it, he ran it, and everything is working fine and magically. Then Furu asked himself, what characteristics should my production container have to deploy it into production? And the answer is basically three things. I need to have a good base image that contains my runtime dependencies that my application needs during runtime. I need my production image to be as small as possible. And I need my container to have a fast startup. And first things first, when we're talking about the base image in the context of Java, we're talking about the JDK itself. And there were a huge discussion lately in the Java community, especially after the new release cadence, which is now 6 months based, and the new licensing from Oracle. But Java is still free, and this is the power of the Java community. So Java is still free, and there are many providers that are offering the JDK for free. And if you need support, there are many providers that are offering that as well. And as Dr. Fingat Subramaniam says, there is no such thing as end of life if you have enough money. So the next thing we want from our production image is to be as small as possible. And for that, there are a couple of techniques that can be followed from both the Java side, from both the Java side and the Docker side. So from the Java side, there is a project introduced back in Java 9, which is Java modularity, or historically it was called Project Jigsaw. So Java modularity enables us to tailor the JVM to select only the modules that we need during runtime. It enables us also to build our own custom GRE, putting the JVM in a strict type. Techniques like code refactoring and code reviews helps to reduce the overall lines of code, reduce the logic complexity, and even detect if we are using a whole dependency for just a small utility function. And talking about dependencies, there are tools both in the JDK itself, like GDEBs, and tools available in both Maven and Gradle that help us to detect what are the dependencies that we are effectively using during runtime, and what are those zombie dependencies that we are not using. That was from the Java side. From the Docker side, from the container side, there are a couple techniques that achieve or enables us to generate a smaller image. Starting by using a smaller base image. And the smaller your base image is, the smaller your final image will be. Also, understanding the concepts of layers and caching of Docker helps to reduce the size of your final image. And generally speaking, is it a good idea to combine the related comments in your Docker file while separating the unrelated comments? Also cleaning up right away. And while working with containers, it is kind of a general practice of downloading an archive, extract the archive, do some modification with the files, and then forgot to remove this archive. So removing this kind of files, and as well as some log directories and some caching directories, helps you reduce the size of your image. Another thing is understanding the build context and using Docker ignore helps to reduce the size of your image. And depending on your application, you might want to ignore some kind of files like the .git directory, some log directories, and some temp directories. And one nice side effect about using Docker ignore, it has helped to speed up the build process, since the contexts, which are the files that are sent from the Docker CLI to the Docker daemon, are now fewer. Also using multi-stage build. And the multi-stage build is used a couple of years back in Docker, and it enables us to separate the build stage or stages from the production stage, keeping our production image clean without the unnecessary build dependencies. There is also an important question that you need to ask while building your image, is whether to keep your assets on your image or download them later on during runtime. And there is no ultimate answer to this question, but answering it will impact heavily the size of your image. And finally, we can use some tools like Docker Squash or Docker Slim. And what these tools basically do, they try to squash the image layers in your image in order to generate a new image with fewer layers. And there is an experimental option in the Docker build command, which is like --squash, which is intended to do basically the same thing. And while I mentioned using a small base image, one Linux distribution comes to mind, which is Alpine. And Alpine is the ideal Linux distribution for many applications out there. And Alpine is a very lightweight Linux distribution, and its size is under 4 megs, I think. And it's based on muscle libc and busybox. So very briefly, busybox combines tiny version of common Unix utilities into one single executable, while muscle libc is an implementation of libc as in the standardized interface. And this is basically the standardized interface between the userland and the kernel. But there is one big difference between Alpine and other common Linux distributions that we are familiar with, and that is those other Linux distributions are based on glibc, which means that C and the C++ code that is compiled with glibc will not work on muscle, and vice versa. And you may be wondering why a Java guy in a Java talk mentioning C and C++ code. And the reason is that we as Java developer, we are using a software that has a lot of C++ code that enable it to do a lot of its function, which is the JVM itself. So in order to ensure a transparent run of the JVM, there is some code modification that needs to be made on the JVM. And luckily, such a project exists, and it's called Project Portola. And it's still on the early access phase. It started on Java 12. It has been pushed to Java 13 and Java 14. I think it will be pushed to Java 15 as well. And you can start contributing to it, start testing it as part of the early access. And you may find on the internet, on Docker Hub, many images, Java images that are based on Alpine, and like the Adobe's OpenJDK repository. And what these guys are doing, they are basically adding glibc Alpine package on top of Alpine. They are not using Project Portola or any muscle port on the JVM. And this slide shows clearly the impact of the base image on the overall size of your final image, and the winner is clearly the OpenJDK 8 GRE based on Alpine, followed by 2 other images of Java 8 and Java 11 coming from Google Cloud Registry. And those images are part of a cool project from Google called Desireless Container Images. And this project aims to create images that contains only your application and its one-time dependencies, restricting what's inside your application to exactly what your application needs to perform its function. Those images are built using Google Bazel tool. They support multiple languages, including Java, of course. And one nice thing about this project is the base image they are using is a very lightweight Linux distribution. Its size is almost 8 megs. And it is glibc based, which can be considered as a nice alternative to Alpine. And someone would ask, why should I care about making my images smaller? And the short answer is the smaller is better. And the long answer is everything in your container is something that the provenance needs to be tracked and need to be scanned for vulnerabilities. Secondly, every time you are pushing or pulling your containers, you are incurring costs in terms of, you are incurring expenses, sorry, in terms of data transfer costs and time. And finally, the smaller your image is, the fewer components it contains, the smaller the service attack. And the third thing and final thing I need from my container image is to have a fast startup. And there is a common belief that Java has a slow startup, and this is true, since the JVM is a complex piece of software engineering that has a lot of, that does a lot of stuff when it starts the application. But the issue is known in the Java community did an amazing job making the startup time of Java application a lot faster. And we see some improvement with each new version, and the easiest way to benefit from that is to start using the latest version of Java, or at least Java 11, which is the LTS version now, as it has the fastest startup compared to Java 8 and Java 9. Other techniques exist as well, like class data sharing, ahead of time compilation, and GraalVM. And let's see actually this stuff in action. So I have a small project here, which is, I think that's too big. The guys in the back, can you see my screen? Cool. So I have here a small Java application based on Niche, which basically starts a Niche server, and whenever it receives a request, it prints hello world. And my goal here is just to measure the startup time. So what I'm doing here is starting the server, and once the server is bootstrapped, I exit the application. So my goal here is just to measure how much the application took to start, right? So here is my Niche application, and I have also a Docker file for each branch. So the project is a multi-branch project, and each branch is a multi-branch project where each branch represents a feature to either improve the startup time or improve the size of my image. And the master branch, I call it the plain branch, where I'm simply running the application with no optimization whatsoever, just on Java 13, right? Okay, where is my terminal? Now I need to, new terminal, sorry guys. Okay, so again, check out. And the first optimization I'm going to do is with CDS. So CDS stands for class data sharing. And before executing your application, the JVM does a lot of preparatory steps. So given a class name, it will look up for the class name in the jar, it loads it, it verifies the bytecode, and then it puts it into an internal data structure. This takes some time, obviously, and it is more noticeable when the JVM needs to do this thing for hundreds or even thousands of class files. But the thing is, as far as the code inside the jar does not change, this class data will be exactly the same, which means that the JVM needs to do each time the same exact preparatory step to generate the same exact class data. And here comes the idea behind class data sharing. And the idea is to generate this data once, dump it into an archive, and reuse it for future launches. And we can even share it simultaneously between multiple JVM instances and multiple containers. So here I'm using Java 13, and Java 13 comes with a much simplified way to use class data sharing. And we do simply that by specifying the archive classes at exit, and it will automatically generate an archive for us. And here I'm using the multi-stage build. So on my build stage, I'm generating the archive, and in my production image, I'm using this archive by enabling the class data sharing, the sharing functionality or sharing feature, and then specifying to the JVM where it can use this archive. If you are using versions before Java 13, things were a little bit more harder. So we need first to generate a list of application classes using the dump loaded classes list option. And then we dump the archive by specifying from the list that we generated, basically. Another technique we can use to improve the startup time is ahead-of-time compilation. So how many of you are familiar with just-in-time compilation? Okay, so very briefly, the GVM collects during runtime some profiling information, and based on this profiling information, it compiles the most executed code into native code, and that enables the GVM to generate highly optimized code and improve peak performance. However, and that's called basically just-in-time compilation, or JIT for brevity. But the GVM does not benefit from JIT compilation during startup time, since the code is not yet JIT compiled. And here's the idea behind ahead-of-time compilation, which aims to compile the code ahead of time, some code, into native code, and improve the warm-up period. So for that, we use a utility called GEUTC command, and we need to provide it with the list of methods we want to use. We want to compile to a native code. And this list we generated by using two options, the lock-touched methods and print-touched methods at exit. So this basically will print all the methods that we use, and then we need to do some modification for this file by adding a prefix. So this prefix is either compile only or exclude. Compile only to compile the method, exclude to ignore the method. And then we use the GEUTC command to compile this list of methods. We can choose the module that we want to compile into native code. We can pass the jar and many options. So using GEUTC, we'll generate a native binary. And then in my production stage, what I'm saying to the GVM to use this native binary, I specify where it can find this native binary. So during startup, what the GVM will do is basically look for this method. If it's already compiled, it will basically load it and send off doing co-compile it from scratch. So those were some techniques to improve the startup time. And the last one is a cool project from Oracle Labs called GraalVM. How many of you are familiar with GraalVM? Cool. So GraalVM is a universal virtual machine from Oracle Labs. And it's basically a universal virtual machine for multiple languages like Python, JavaScript, Ruby, and many GVM languages. But what excites Java developers for GraalVM is a sub-project called Substrate VM, and it enables us to compile our application ahead of time into native code, so we can execute our application without the need of a GVM. The same thing we can do with C and C++ application or Go application. So for that, I'm using the native image utility. So I'm using the base image GraalVM Community Edition. I'm downloading the native image utility and using this utility to compile my Java application into native binary. And then, as you can see here, I'm using no base image. I'm starting from scratch and then adding my simple native image, my simple native application, and running it. And that's basically it. So those were some techniques to improve the startup time of my application. I've mentioned it using Java modularity. Java modularity. Please remove. What the hell is wrong? Okay. Don't save. Switch. What happened? Get status. Did I modify something? Nothing added to commit. Get. Checkout. Alpine. Come on. Please move. Okay. Get. This is not safe for work, but okay. Modularity. What the heck? Wow. Okay. dash dash cached, right? Cached, and then this file. Something is wrong here. Please, now. Okay, what the hell is happening? Full untrack info-tree, rich invite checkout. Come on. Oh. Oh. What did you say, sorry? Which means I should go back to, okay, which is located here, okay. Yep. Modularity. Now we go. Thank you. Okay, so I was talking about modularity, and this is basically the Java module system, and we can here select the modules that we need application to run, and as you can see here, I'm adding the Java-based module, login modules, and a bunch of other modules, and then specifying my own custom GERE here in my build stage, and then I using this my custom GERE to run this my application. We can do the same with Alpine and use Project Portola instead. Let's see here. So I'm doing the same exact thing here. Simply using, instead of a regular JDK, I'm using the early access to Project Portola as part of the early access of Java 14, and I'm using the same thing, and then using Alpine as base image, and then using my own custom GERE. So if I go back to my master branch, I have a small benchmarking script basically, which measures the startup time of my application. Okay, this is too small. Which measures the startup time of application, which basically run each and every image, and then measure the time it took for the application to start and the size of the image. If I run the image, if I run the benchmarking script, I will have some results that look exactly like this, or more or less. So compared to the plain branch, using the modularity, I achieved some improvement in the size of the image. And by using AUTC and CDS, I improved slightly some improvement of the startup time, but using GraalVM, I improved like much better in terms of the size of my image and the startup time of my image, which is like crazy for a Java application. So those were some techniques to improve the startup time of my application or to reduce the size of my image. So going back to the presentation, containers changed the way we develop, architect, and deploy our applications to become the executables of the cloud. However, our friend Farouk thinks that containers added kind of some layer of abstractions and make it, especially for Java developers that we are already familiar with the standard packaging format, which is like jar file or WAR file, added a new layer of abstraction. So now we have to generate our jar files and then generate the image, which is the new packaging format for the cloud. And was wondering if we can use the same good old tools that we are using for packaging our standard packaging our standard format for Java applications, like Maven and Gradle, and use them to generate this new unit of deployment, which is containers. And luckily, such plugins exist for both Maven and Gradle. And the easiest way to achieve that in Maven is to inject the Docker comments into Maven lifecycle using Maven exec plugin. However, this solution is not so elegant, and other more robust, more sophisticated plugin exists, such as Dockerfile Maven plugin from Spotify, and this plugin is the embodiment of simplicity, as it does basically two things. It generates the container image, and then it deploy it, push it into a registry. Another more robust plugin exists, this time from Fabric8, from the Red Hat folks. And it does a lot of things. So it can build the image, push it into a registry. You can view the logs, create networks, create volumes, and a bunch of stuff. If you're a Gradle fan, there are many tools that enable you to work with containers and manage them from Gradle tasks. Another project worth mentioning is Jib. And Jib is a very cool project from Google, and it's a pure Java library that is available in both Maven and Gradle, and it enables us to build our image without the need of a Docker file and without the need of a Docker daemon installed in our machine. And what Jib basically does is somehow similar to what in this Docker file. So Jib does not use any Docker file, but if it did, it will look something similar to this one. So Jib understands our Java application, split it into multiple layers, putting the files that are less likely to change on the top, and the files that are more likely to change on the bottom. And that helps us to speed up the build process, since now if we change it some files, we only build one layer instead of building the whole application. It also helps ensure reproducibility. So not change, the generated image will be exactly the same. Another cool project, this time from Docker, under the Moby umbrella, which is BuildKit. And BuildKit is meant to be the next backend implementation of the current Docker builder. And it's meant to solve a lot of problems that we are facing with the current Docker builder. It comes with a concurrent build graph solver that can execute the Docker build comments in parallel. It keeps track of the modified files, so it loads only the modified files during the build, and it approves reading from the file system. But what I want to talk about here is the #1 complaint of Java developers while working with containers, which is building your containers from building your Java images from Docker. Because of this false dependency that the Docker builder has between the layers, even if you change a comment file in your code, you need to run the Maven build step and download the whole internet. Even if you change it, even you don't change it anything in your code, just a comment. And the build kit comes and extends the Docker syntax as part of the experimental Docker file, and it extends the run comment to add a mount type. And there are many types here, but what interests us is a particular one, which is the cache type. And the cache type here tell Docker or tell the builder to save this directory, some files or some directories, to cache them and then reuse them for future builds. So it will download for the Java application. You can mount your local Maven repository, and then it will download the internet in the first time. But it will simply get the file directly from the cache directory without downloading everything. It really helps to speed up building your jar files or WAR files directly from containers. Another important practice while working with containers is image versioning, and there are many techniques that can be followed to tag your images, and nothing stops you from combining those techniques. And it's really important to version your images, since it helps you to track at any moment in history how your containers looked and how your application behaved. Another thing is to avoid using latest in your Kubernetes or containers orchestration configuration files, because of three things. It is not dynamic, which means that if the tag is neither empty or you explicitly specify latest, it will not be added by default. It is also not descriptive, which means that things like rolling updates or rollbacks is not possible, since all orchestration tools rely on separate tags to roll updates and do rollbacks. And since it's the default value, it is easily overwritten, and it can be like a problem of human errors or a concurrent modification. Another important topic is the security while working with containers, and I believe there were many great sessions at this conference about security in containers and Kubernetes in general. But my goal here is just to give you some bullet points to keep in mind while working with containers. Starting with knowing what's inside your containers, especially if you are using third-party containers, you need to make sure that those containers are not downloading anything during runtime. Also, you have to make sure that the code inside your application does not contain any malicious scripts or is safe, and you can do that by running your application code for against SaaS tools or vulnerability scanning tools to help to detect vulnerabilities. You can do the same thing with your container images and scan them for vulnerabilities, and there are many tools, open source and commercial, that helps you to achieve that. Another thing is try to sign your images and use as much as you can Docker Content Trust. And once Docker DCT is enabled, so when you push the image, the Docker daemon will sign your image using your private key. When a later user wants to pull the image, the Docker daemon will automatically verify the image using the publisher private key. It will verify it for authenticity, integrity, publishing date, and a lot of stuff. Another important principle to adhere to is the least privilege principle. And in the context of container, it means that you need to run your application with the container and the processes with the minimum set of access rights and resources that enable your application to perform its function. And this enables us to, even if an attacker succeed to exploit a vulnerability, it's still very limited on the damage that can make to your cluster. A couple of steps can be followed to achieve that, starting with making sure that the processes running inside your container are not running as root. So an attacker, if he succeeds to hack your system, he will not have a root access. Also, if you don't need a write access, run your file system as read only. So an attacker cannot modify data or save malicious scripts. And finally, limiting the resources that can be used by a process can help to avoid some kind of attacks like DOS attacks. Also, as explained previously, having a minimal container OS helps to reduce the service attack. And finally, having some monitoring tools in place helps to detect unusual behavior and trigger alerts. And another important practice, but not related necessarily to containers, but in software engineering in general, is testing. And testing is a little bit hard, especially integration testing, since it is hard to achieve this real isolated environment in integration testing, since our application needs to communicate with databases, call other services through HTTP or gRPC or whatever, and probably they need to send some emails and they need some SMTP and stuff. So containers help it to create this real small isolated environment. And if you are a Java developer, there is a cool library called test containers. And test containers helps to manage containers during test time. So it supports many JVM testing frameworks. It comes with a lot of great features, like it provides lightweight throwaway instances of common databases. It offers port randomization, and it automatically cleans up the containers after JVM shutdown. And it's really easy to work with and fun to work with. So with that, our friend Ferro wants to deploy its container into a big server after he successfully managed to build its own application. So let's go back to my demo here and just want to show you. Okay, please, SB. So I have, so I'll be running my application on Java 8 update 121. And I'm running my Java application with two options, which show settings, which enable me, which I'm telling the JVM basically to print the settings during startup time. And I'm tracking the memory, but only as summary, so to not impact the performance of my application. So running the application, Docker run. Okay, and the application, it's basically this one. So the GVM, oh wow, that's too big. So, so the GVM printed the configuration it used during startup. So it says here that it used 2 gigs of the maximum heap size. You notice that I didn't specify neither the maximum heap size or anything. So basically, this is part of a cool feature of the GVM called the GVM ergonomics, which basically the GVM try to ensure the best performance on the execution environment. And it does that by collecting some information from the underlying host. So by default, it specifies 1/4 of the available system memory as the maximum heap size and 1/64 as the initial heap size. And if I checked my, okay, it's hard to code with one hand. Docker. Okay, info. No, info. As you can see here, I'm using basically Docker for Mac, and it's a virtual machine. And you can see that I'm allowed to Docker to use up to 8 gigs of memory. And the 1/4 of 8 mix is almost 2 gigs, right? So my application is running, and let's take a look to it. So it's basically a pit store application where I can find owners or add owners, and it shows me the list of my owners. So just a simple Java application, nothing fancy about it. So let me stop this application. And while working with containers, we want to limit the resources that a container can use from a security perspective and from a resources utilization perspective, right? So what I'm going to do here is I'm going to specify that my application can use only 250 megs of memory, right? But notice here that the application or the GVM still thinks it can use up to 2 gigs of memory, completely unaware of the limitation I have just put, which is kind of 250 megs. And what will happen if my demo works correctly, and the demo gods are with me today, so the application will actually fail to start, as it happened today, as it happened now. And as you can see, the application failed to start. And if I inspect this container, you can see that it received a out of memory kill signal somewhere, which is the OO. This one. It received an out-of-memory kill signal because the container was using more memory than it allowed to do. And basically, the Docker daemon noticed that, and it sent a kill signal to the container. And if you were using some orchestration tools like Kubernetes, you will notice that your application is restarting and restarting and restarting, unable to reach a stable state. So I'm a Java developer, and when I have a memory problem, what I generally do is I add more memory. So let's add more memory. Okay, not this one. Okay. So I'm specifying 500 megs to my application, but notice here that the application still unaware of my limitation. It uses up to 2 gigs of memory. But how many of you think now that the application will start? Will not start? Okay, a couple of hands. The application will actually start. And this will not happen on a server with bigger resources, but it happened on my machine. And if you remember, I specified in my Java flags that I want to track the memory. So there is a utility available in the JDK, which is the G command. A G command enables me to send diagnostic requests to GVM and get answers about a lot of things, like the threading, the memory, the Java flight recorder, and a lot of stuff. So here I'm asking it about the native memory and specifying the scale to megabytes, right? What's the name of my container? Sorry for that. Come on. Give me the name. SPMS. What? slash? Dash, okay. Nope. It's MBS dash? Ah, okay. Oh. Okay. So, yeah. So the application, so as you can see here, my container or the GVM is using more than 500 megs. It's actually using 800 megs. So you may be wondering where this additional memory comes from. And the quick answer is my application is actually swapping. The application is using swap. And it will impact the performance of your application. But if we enable the swap, and we can do that by using the dash. Normally we do that on the host level, but we can simulate the same thing using the dash dash memory swap option and specifying the same value as the memory. Okay, it should be fine now. Name must be low. Okay, which name? Okay. Yeah. And I need to specify the name here. Okay. So, how many of you now think that the application will actually start? 0. Will not start? 0 as well. Who doesn't care? Oh no. So normally it should not start, so I miss it. I should miss it something. Okay, so the demo gods are not with me. Okay, let me check. Normally there will, so the memory swap thing is the same value. It should not start. But you got the idea. So the application will swap in, and normally if I disable swapping, it should not start. But I don't know. I probably missed something in the configuration. And my screen looks huge. Anyway, you got the idea, and that the GVM is not container aware. And our friend Farouk is pissed off and wants to understand why the application that was working perfectly in his local machine failed badly when he went to a bigger server. And the first part of the question comes from history. From the answer, sorry, comes from history. So the containerization movement started back in 2000 with free BSC jails and Solaris zones. And the backbone technology behind containers, C groups and namespaces appeared in 2006 and 2008. And when Docker appeared in 2013, the containerization movement exploded in popularity. However, Java was there since 1997. And when Docker first appeared in 2013, Java 7 was already out, and the work on Java 8 already started, which explains somehow why the GVM is not container aware. Another part of the answer is the GVM ergonomics, and I talked about it briefly during the demo, but GVM ergonomics is a nice feature of the GVM, which enables it to ensure the best performance on the execution environment, and it does that by collecting some information from the underlying host. But if the GVM fails to get those information from the correct place or get the wrong information, this feature turns out to be a nightmare. And we see what happened when the GVM fails to get the right values of the memory. But the same thing could happen with the CPU. And if the GVM fails to get the correct number of CPUs, this will impact the internal threading pools. It will impact some popular GVM APIs like the fork join API and the streaming API. It will impact some popular Java software that we are using. So the issue is known, and the Java community started the work to make the GVM more container aware. Unfortunately, if you are using Java 8 update 121 or before, the JVM is completely anywhere. And the only option you have is to specify those options to the JVM, or you can use a nice shell script from the Fabric community. It's kind of a cool hack. What they do is basically collect the information from the cgroups limitation and then provide the JVM with the good values. In Java 9, we started to see some improvement in the Java to make it more container aware, with some options to calculate to specify the number, and some experimental options to configure the memory. And good luck convincing your manager to choose an experimental options in production. In Java 10, a lot of features has been introduced to make Java more container aware, with more options that allow more fine-grained control over the memory that can be used by the JVM. A new formula has been introduced to calculate the total number of CPUs, and a new options, which is the active processor count, which enables us to specify the number of processes that can be used internally by the JVM. And also, there were some attempts to make the gcomment and gstack more container aware. In Java, in Java 11, the work continued to make the JVM more container aware with the introduction of container metrics, which is basically an internal API to collect the container configuration and runtime metrics. And there is a new option that has been introduced, which is prefer container quota for CPU count, that basically aims to solve an underutilization issue that appeared with Kubernetes. And the work continued to run GCMD and GPS comment. You have a question?
Yeah, you're not showing backporting to Java 8. Will you stop doing that?
I think no. They continue to do that. But it's hard to track since they are moving so fast, so I kept with the latest version, but I believe those options were added, and this one, this one as well. So I think everything, because it's not Oracle that is leading this now, so Oracle is focusing on the latest version, and it's another team which is led by Red Hat that backports all the features to Java 8. So it's hard to keep track on the OpenJDK box stuff. So it's like two separate teams. But I believe this feature of Java 11 has been backported to Java 8 as well. Great question, thank you. And in Java 12 and Java 13, the focus was to make some tools more container friendly, like GHSDB and Java Flight Recorder. Okay. The efforts continued in Java 14 and Java 15 to make the Java Flight Recorder more container friendly, and they are working on the support to support cgroups v2. And there are many bugs and features introduced by the community to make Java more and more container aware. So it is never a good idea, finally, so this is before my last slide. So it is never a good idea to deploy your application in production without having monitoring tools in place. So from the Java side, there are tools that are available in the JDK itself, and tools and open source tools and commercial tools that help you to detect how your application is behaving in production. From the container side or the Docker side, there are many tools, like some comments in the Docker and kubectl, and many open source and commercial tools that enables you to keep an eye on what's happening on your container. So is it actually a good idea to deploy a Java application inside a container? Yes, definitely, you will gain a lot, but keep in mind that the Java is not completely container aware. So it is container aware now, but there are some problems. It is better than it was like 3 or 2 years back. But keep in mind that Java has a strong and rich ecosystem with many tools and libraries that enable you to work better with Java and containers. And thank you. I still have, thank you. I still have 3-4 minutes if you have any questions. Yeah. Yeah. So the GitHub link, okay. No, still, this one. Yeah, okay. Yeah. You're talking about Coral VM, or you mean with the improvement of the startup time? So the answer is how we can, with the improvement I showed, how we can get can we get the startup, improve the startup time with some real world frameworks like Spring and Micronaut and stuff. Yes. So there was a huge improvement, especially in the CDS, and the startup time of, if I remember, the latest version of Spring is less than 1 second. You can have a lot of improvements with, if you are working with another project from Red Hat, what is called Quarkus. So Quarkus, because Spring rely a lot on reflective stuff, reflection, right? So Micronaut and does not rely on reflection at all, and Quarkus they do that on the compilation time. So the startup time is a lot more faster. But with the latest version, especially with CDS, the improvement is huge. You will have your application starting in less than a second. Yes. You mean startup on execution? So the improvement is, the startup time, so the answer is, the question is, the startup is, there's improvement in the runtime compared to the startup time. So the GVM is the rate on runtime because you have JET and the improvement is there. But with the containerization movement and the serverless movement, there start to be some worries about the startup time. So yes, the runtime is the improvement on runtime is still there, but there were a lot of demand right now with the rise of serverless to make the startup time a lot more faster, because you pay as you go, and if you lose a lot of time waiting for the application to start, that's a lot. One more question. Yes. Uh-huh. Spring tools like? Yeah. So there is a new feature I introduced by the Spring team. I think it will appear in the next version, but it's based on the build packs, I think. But there is a nice integration between Jib and Spring. So you can build your container image directly from Jib without the need of a Docker file and stuff. So you don't need a Docker daemon. You just need a registry there. So you can only have Java and Maven installed, and you can build your image and push it into your registry. Is that answer your questions? Uh-huh. I prefer to use, I'm personally using Jib. I love Jib a lot. Welcome. I think I'm out of time. Thank you very much.